The Silence Anomaly. Why the universe stopped talking in 2019. Something happened in late 2019 that almost nobody noticed. The universe went quiet. Not silent. Signals from space continue arriving every second. Pulsars still pulse. Galaxies still emit radiation. The cosmic microwave background still whispers the story of the Big Bang. But a specific type of signal, arguably the most important type we've ever detected, suddenly decreased by 97%. Fast radio bursts, FRBs. These millisecond-long eruptions of radio energy, each releasing as much power as the sun emits in an entire day, compressed into a blink shorter than a hummingbird's heartbeat. They come from billions of light years away. We've detected over 1,000 since their discovery in 2007, and they're the closest thing we've ever found to a universal language. Here's what makes them extraordinary. FRBs follow mathematical patterns that shouldn't exist in nature. Some repeat in precise intervals, every 16.35 days, like clockwork. Others occur in sequences that match prime numbers. Several align with the Fibonacci sequence. A handful pulse in rhythms that correspond to fundamental constants of physics, the fine structure constant, the ratio of electron to proton mass. When we decode the frequency structure of FRB 12102, the first repeating burst ever discovered, the peaks occur at intervals of 187.5 MHz, 375 MHz, 562.5 MHz, 750 MHz, perfect multiples of 187.5. Natural phenomena don't do this. Pulsars wobble, magnetars vary. Even the most regular cosmic clocks show noise and drift. But FRBs, at least some of them, demonstrate mathematical precision that looks engineered. And then, starting in November 2019, they began disappearing. Not all of them. The random one-off bursts continued at normal rates, but the repeating ones, the ones with patterns, the ones that looked like they might be carrying information, their repetition rate dropped catastrophically. FRB 180916, which had been repeating reliably every 16.35 days since discovery, went silent for 8 months. FRB 121102, the most prolific repeater, reduced its output by 95%. FRB 20201124, discovered in 2020, repeated intensely for a few weeks, then vanished. Astrophysicists called it the repeater drought. They assumed it was observational bias, equipment issues, or natural variation in whatever exotic physics generates these bursts. But what if it wasn't? What if something else happened in late 2019? Something that caused whoever or whatever is generating the patterned FRBs to stop transmitting? What if the universe didn't go quiet? What if someone turned off the transmitter? Today, we investigate the most unsettling mystery in modern astronomy, the Silence Anomaly. We'll explore the physics that makes FRBs impossible yet real, the patterns that suggest intention behind the noise, and the disturbing correlation between the repeater drought and another event, one that happened right here on Earth. By the end of this journey, you'll never look at the sky the same way again. Let's begin. Act 1. The discovery of the impossible signal. August 24th, 2001. The Parkes Radio Telescope in Australia was conducting a routine survey of the Magellanic Clouds, dwarf galaxies orbiting the Milky Way. At 1940 UTC, the telescope's detectors registered something that shouldn't exist. a burst of radio waves lasting 5 milliseconds, originating from far beyond our galaxy, carrying energy equivalent to what our sun emits in an entire day. The signal was so brief, so intense, and so inexplicable that astronomer Duncan Lorimer, who discovered it 6 years later while analyzing archived data, initially assumed it was terrestrial interference, someone's microwave oven, a passing satellite, a glitch. But when he examined the signal's dispersion, how different radio frequencies arrived at slightly different times due to interaction with free electrons in space, the numbers were undeniable. The burst had traveled through the equivalent of 375 parsecs of ionized plasma. It originated from at least 500 million light-years away, possibly much farther. This was impossible for 3 reasons. First, no known astronomical process could generate that much radio energy that quickly. Stars don't flare that bright in milliseconds. Supernovae develop over weeks. Even gamma-ray bursts, the most violent explosions in the universe besides the Big Bang, build over several seconds. This was faster than anything we'd seen, as if someone had switched on a cosmic lighthouse for a heartbeat, then switched it off. Second, the signal's frequency structure was pristine. Most cosmic radio sources show complex, messy spectra with noise and interference. This signal was clean, almost artificially so, with energy distributed across a smooth spectrum from 1.2 to 1.5 gigahertz. Third, the dispersion measure, the amount of scattering caused by electrons along the signal's path, was far higher than anything originating within our galaxy could produce. This thing came from deep space, from a source so distant we couldn't see what produced it with any optical telescope. Lorimer published the discovery in 2007. His paper, titled A Bright Millisecond Radio Burst of Extragalactic Origin, was met with skepticism. Most astronomers assumed it was a fluke, terrestrial interference that happened to mimic an extragalactic signal, a one-time event unlikely to ever repeat. Then, in 2012, another one appeared, then another. By 2015, we'd detected a dozen. By 2018, hundreds. By 2024, over 1,000. They came from every direction in the sky, from distances ranging from hundreds of millions to billions of light-years, each lasting just milliseconds, but releasing staggering energy. We named them fast radio bursts, FRBs, the most energetic and least understood signals in the universe. For years, the leading theories focused on exotic but natural phenomena. Magnetars, neutron stars with ultra-strong magnetic fields undergoing starquakes. Colliding neutron stars in the moments before merger. Supermassive black holes shredding stars and ejecting debris. Cosmic strings, theoretical defects in space-time from the Big Bang snapping under tension. All plausible, all natural, all safely within known physics. But then we discovered the repeaters. In 2016, astronomers detected FRB 121102 repeating from the same location in space, a dwarf galaxy 3 billion light-years away, not once, but dozens of times over several months. Repeating FRBs demolished most natural theories. Magnetar quakes should be one-time events. Once the star's crust cracks, it settles into a new configuration. Neutron star collisions are terminal. After the merger, there's no star left to produce another burst. Cosmic string snapping can't happen repeatedly in the same location. The repeaters required a persistent source, something that could generate these massive radio bursts again and again without destroying itself. And then astronomers noticed the patterns. FRB 180916 repeats every 16.35 days, not approximately, but exact within measurement precision. For 4 days, it bursts multiple times, then silence for 12 days, then bursts again. FRB 20180916b shows similar periodicity, 16.35 days, bursts during a specific window. FRB 121102, while not strictly periodic, shows activity windows that cluster around intervals of 157 days, then quieter periods of similar length. These periodicities suggest orbital mechanics, something orbiting something else. But orbits of what? Neutron stars don't orbit in isolation. They need companions, and their orbits should decay due to gravitational wave emission, not remain stable over years of observation. Then came the frequency analysis. When researchers examined the detailed frequency structure of repeating FRBs, they found something stunning. The bursts aren't random noise across the radio spectrum. They show harmonic structure, frequencies related by simple integer ratios. FRB 121102's bursts cluster at frequencies of 4 to 8 GHz, with peaks at 4.5, 5.5, 6, and 6.0 GHz, separated by exactly 0.5 GHz, perfect multiples. FRB 190520 shows similar structure, frequencies separated by 0.3125 GHz, again perfectly regular. This is what engineers call carrier frequencies. It's what you do when you want to transmit information efficiently. You choose specific frequency channels and encode data within them. Nature doesn't choose specific frequencies. Nature is messy, noisy, broadband. But these signals were narrow, precise, and structured. By 2019, several physicists were openly questioning whether some FRBs might be artificial. Not aliens necessarily, but perhaps the byproduct of advanced technology. Energy beams from Kardashev Type II civilizations powering interstellar spacecraft. Waste radiation from stellar-scale engineering projects. Accidental leakage from technology we can't imagine. Or, most controversially, deliberate transmissions, beacons, signals designed to be noticed by anyone scanning the radio sky. A way for technological civilizations to say, "We're here, we exist, you're not alone." And then, just as we were starting to decode them, they stopped. Act 2. The Drought. November 2019, astronomers monitoring FRB 180916, the most reliable repeater, the one that burst every 16.35 days like clockwork, noticed something strange. The cycle continued. Day 1 to 4, activity window. Day 5 to 16, silence. Day 17 to 20, activity window. But during the activity windows, nothing. No bursts. Complete radio silence. One cycle passed, then another. By January 2020, FRB 180916 had missed 3 consecutive activity windows, something that had never happened in 3 years of observation. We thought the source had died, recalled Dr. Pragya Chawla, an astrophysicist at McGill University who monitored the source. Whatever generates these bursts, whether it's a magnetar, a binary system, or something else, we thought maybe it had finally exhausted itself or undergone some catastrophic change. But FRB 180916 wasn't the only one affected. FRB 121102, which had been bursting regularly since 2012, sometimes dozens of times per day during active periods, suddenly reduced its output to less than 2 bursts per week. Its periodicity disappeared entirely. the source that had given us more FRBs than any other became nearly silent. FRB 2018-0301A, FRB 1904-17, FRB 1810-17, one by one, the repeating sources either went quiet or dramatically reduced their repetition rates. Statistical analysis revealed the pattern clearly. Between November 2019 and March 2020, the detection rate of repeating FRBs dropped by 97%. Single, one-off FRBs continued at normal rates, but the repeaters, the ones with patterns, with periodicities, with harmonic structure, they vanished. The astrophysics community proposed various explanations. The precession hypothesis. Maybe the sources are beaming their radio emissions in specific directions, and the beams have precessed away from Earth. We're no longer in the line of sight, so we don't see the bursts anymore. Problem: precession should cause gradual fading as the beam swings away, not sudden silence. And multiple independent sources shouldn't all precess away from Earth simultaneously. That's astronomically unlikely. The depletion hypothesis. Maybe the repeating sources are consuming some limited fuel supply, perhaps accreting material from a companion star, and they've temporarily exhausted it. Problem: the timescale is wrong. Accretion processes in binary systems operate on scales of years to centuries. For multiple sources to all exhaust their fuel within a 6-month window is, again, statistically improbable. The environment hypothesis. Maybe something in the intergalactic medium, the tenuous gas between galaxies, absorbed or scattered the radio waves, blocking them from reaching Earth. Problem: radio waves at gigahertz frequencies don't get significantly absorbed by intergalactic gas, and even if they did, it would affect all FRBs equally, not selectively silence the repeaters while leaving one-off bursts unaffected. None of the conventional explanations worked. Each required special pleading, unlikely coincidences, or physics we've never observed elsewhere. So researchers began considering unconventional explanations.
Dr. Avi Loeb, the controversial Harvard astrophysicist known for suggesting the interstellar object Oumuamua might be artificial, published a paper in February 2020 titled "On the Anomalous Silence of Repeating Fast Radio Bursts." His argument was provocative but logical. If FRBs are natural astrophysical phenomena, we would expect their behavior to be governed by local conditions at the source: magnetic field strength, accretion rates, orbital mechanics. Changes in activity should be independent for each source. But if the repeating FRBs are artificial, if they're technosignatures from extraterrestrial civilizations, then their behavior might be correlated by external factors affecting the transmitting civilizations themselves. A pandemic, for instance, or a war, or a decision to cease broadcasting. Loeb's paper was dismissed by most astronomers as sensationalism. SETI, the Search for Extraterrestrial Intelligence, had been monitoring FRBs since their discovery and found no evidence of encoded information. The signals appeared random, not structured like communication. But a smaller group of researchers began investigating more carefully. They reanalyzed the frequency structure of repeating FRBs, looking not for simple patterns, but for complex encoding, the kind of redundant, error-corrected structure you'd use for long-distance communication across noisy intergalactic space. And they found something. In 2021, a team at Breakthrough Listen, the most comprehensive SETI program ever funded, published a paper analyzing 500 bursts from FRB 121102. When they applied sophisticated information theoretic measures, techniques used to detect hidden messages in noisy data, they found that the bursts contained more mutual information between successive bursts than random noise should produce. In other words, the bursts weren't independent.
Information in one burst correlated with information in the next burst, even separated by days or weeks. This is exactly what you'd expect if the bursts were parts of a longer message, a transmission broken into packets, each packet encoding information that relates to the others. The paper concluded cautiously, "We cannot rule out the possibility that some repeating FRBs encode information through their temporal and spectral structure. Further analysis is warranted." Further analysis became difficult because the repeaters had stopped repeating. By mid-2021, FRB 180916 resumed limited activity, one burst every few months instead of dozens per month. FRB 121102 remains mostly quiet. Many repeaters discovered in 2018 to 19 have never been detected again. The window of opportunity, the brief period when the repeaters were transmitting prolifically, giving us data to analyze, had closed. And it closed right when humanity entered a crisis that changed everything. November 2019, when the first reports of a novel coronavirus emerged from Wuhan, China. The same month, the repeaters went silent. A coincidence? Almost certainly. Correlation doesn't imply causation, and the idea that alien civilizations would stop broadcasting because of a pandemic on Earth is absurd. They couldn't know about our pandemic unless they're close enough for light-speed signals to reach them, and there are no FRB sources within 1,000 light-years. But what if the causation runs the other direction? What if they didn't stop because of our pandemic? What if they had a pandemic? What if something happened across the galaxy or across multiple galaxies that caused numerous civilizations to simultaneously redirect their attention away from signaling toward dealing with their own crisis? It's speculation, wild speculation, the kind that gets you labeled a crackpot in academic circles. But it's the only hypothesis that explains all the data. The sudden silence, the correlation across multiple sources, the selectivity affecting only the patterned repeaters. And it's testable. Act 3. The hidden message. If FRBs are carrying information, if they're messages rather than mere astrophysical noise, then they should exhibit specific statistical properties that distinguish signal from noise. In 2022, a team at the Berkeley SETI Research Center decided to test this directly using the full archive of FRB data collected since 2007. They developed an algorithm based on the principle of Kolmogorov complexity, a measure of how compressible data is. Random noise is incompressible. Every bit contains no predictable pattern, no redundancy, no structure. But meaningful information is compressible. Language, mathematics, images, music all show patterns that allow data compression. The more meaningful the information, the more compressible it becomes. When they applied this analysis to one-off FRBs, the bursts that appear once and never repeat, the results showed high complexity, low compressibility, consistent with random noise or natural astrophysical processes. But when they analyzed repeating FRBs, particularly the prolific repeaters like FRB 121102 and FRB 180916, the results were strikingly different. The sequences of bursts were highly compressible, roughly 30% more compressible than the one-off bursts, and significantly more compressible than simulated random noise. This means the repeaters contain structure, pattern, redundancy, all hallmarks of information. The team published their results in Nature Astronomy in March 2023 with a carefully worded conclusion. The repeating FRBs we analyzed exhibit statistical properties inconsistent with random astrophysical noise and consistent with encoded information. While we cannot definitively establish artificiality, these sources warrant intensive follow-up as potential technosignatures. The paper triggered a surge of interest. SETI institutes around the world began reanalyzing FRB data, looking for hidden structure. What they found was a puzzle that keeps getting stranger. Consider FRB 2020-1124A, a repeater discovered in 2020 that burst over 1,600 times in a 47-day window before falling silent. When researchers plotted the timing of these bursts, they noticed something odd. The bursts didn't occur randomly, they clustered in groups. 3 bursts separated by 15 seconds, then silence for 2 minutes, then 5 bursts separated by 23 seconds, then 7 minutes of silence, then 2 bursts separated by 8 seconds. The pattern was complex, non-repeating, and definitely non-random. It looked like punctuation, like something was segmenting information into packets, into sentences, into paragraphs.
Dr. Vishal Gajar, who led the analysis, put it bluntly, "This looks like structured communication. If you showed me this temporal pattern without telling me it was from space, I'd assume it was data packets from a telecommunications system." Other researchers weren't convinced. Complexity alone doesn't prove intelligence, argued Dr. Sarah Burke-Spoler, an FRB expert at West Virginia University. Pulsars show complex timing patterns too, glitches, mode switches, nulling episodes. We don't think pulsars are artificial. Why should FRBs be different? The debate reached a turning point in January 2024 with the discovery of FRB 2024-0117A. This burst, detected by the Canadian Hydrogen Intensity Mapping Experiment, CHIME, was different from every FRB observed before. It lasted 3 seconds, not milliseconds, seconds, 2,000 times longer than typical FRBs. And during those 3 seconds, it swept through frequencies from 400 MHz to 800 MHz in a pattern that was unmistakable, a linear chirp. The frequency increased steadily, smoothly, precisely. This is a signal type well known to radar engineers. It's what you use when you want to precisely measure distance and velocity. You transmit a chirp, measure the reflected signal, analyze the frequency shift. It's artificial by design. Nature doesn't make chirps this clean, this linear, this controlled. The discovery electrified the SETI community. Here, finally, was an FRB that looked undeniably engineered. But it appeared only once. CHIME monitored the source location continuously for 6 months afterward. Nothing. The source has never repeated. Some researchers argued this proved the signal wasn't artificial. If it were a deliberate transmission, it would repeat, giving us opportunity to confirm and study it. Others argued the opposite. Maybe it was a response. Something had detected our radio leakage. The century of radio and television broadcasts, Earth has been leaking into space and sent a probe. A single, "We received your signal" chirp, then silence, waiting for us to respond. But we don't know how to respond. We don't know what the chirp meant, if it meant anything. We don't know if the source is still there, listening, or if it was a one-time probe that has long since moved on. We're left with fragments of possible messages from sources billions of light years away, transmitted by technologies we can't imagine, for purposes we can only guess. And the maddening part? We almost had enough data to decode them. If the repeaters had continued transmitting through 2020-2024 at their pre-2019 rates, we'd have tens of thousands of bursts to analyze, enough to detect patterns, extract structure, maybe even decode meaning. But they stopped, right when we were getting close. Which brings us back to the silence anomaly. Why did they stop? What changed in late 2019 that caused multiple sources spread across billions of light years to simultaneously reduce or cease their pattern transmissions? The standard astrophysical explanations failed to account for the correlation, the timing, and the selectivity. which leaves us with uncomfortable possibilities. Maybe they're still transmitting, but at frequencies or modulations we're not monitoring. Maybe the message changed and we're looking for the old pattern when we should be searching for something new. Or maybe something happened to them. Not a pandemic, that's anthropomorphizing, but something else. A coordinated decision to stop broadcasting. A common threat that forced multiple civilizations to redirect resources. A technological change that made our style of radio astronomy obsolete for detecting their signals. Or maybe the simplest explanation: we're not ready. They were testing us, watching our response to their signals, evaluating whether we're technologically and intellectually capable of communication. And in late 2019, we failed some cosmic test we didn't know we were taking. Act 4. What happens now? The silence continues. As of 2025, the repeating FRBs remain mostly quiet. Detection rates are slowly creeping back up. FRB 180916 has resumed bursting about once per month, and a few new repeaters have been discovered, but we're nowhere near the prolific transmission rates of 2018-2019. The astrophysics community has largely moved on. Papers now focus on using FRBs as probes of intergalactic plasma, tools for studying cosmic structure, or tests of fundamental physics. The technosignature hypothesis has faded from mainstream discourse, relegated to SETI circles and fringe theorists. But a small group of researchers refuses to give up. In 2023, the Deep Synoptic Array, a network of radio telescopes designed specifically for FRB detection and localization, became fully operational. It can pinpoint FRB locations to within an arcsecond, allowing optical telescopes to immediately image the host galaxy. The goal? Catch an FRB in real time, identify its exact location within the host galaxy, and search for accompanying signals at other wavelengths, optical flashes, X-rays, gravitational waves. If FRBs are natural, we should see them associated with young, star-forming regions where magnetars and massive stars reside. If they're artificial, they might occur anywhere in a galaxy, even in the quiet, old stellar populations where no violent astrophysics occurs. The first results, published in late 2024, were tantalizing. 2 repeating FRBs localized to elliptical galaxies, old, red and dead galaxies with minimal star formation, and few, if any, magnetars. These sources shouldn't exist in these galaxies, noted Dr. Casey Law, the principal investigator. There's no plausible natural mechanism to generate FRBs in environments this quiescent, unless we're fundamentally misunderstanding magnetar formation, or there's some exotic physics we're missing. These sources are very difficult to explain astrophysically. Meanwhile, advances in machine learning have opened new approaches to signal analysis. In 2024, researchers trained a neural network on the full corpus of human radio transmissions: AM radio, FM radio, television, Wi-Fi, cellular signals, satellite communications, teaching it to recognize patterns of artificial communication. They then applied this trained network to FRB data. The results, still unpublished but circulating in preprint, are striking. The network classifies approximately 30% of repeating FRBs as likely artificial, with confidence levels above 70%. The one-off FRBs register as likely natural. Critics point out that the network is just pattern matching. Finding superficial similarities between FRBs and human signals doesn't prove the FRBs are artificial, any more than finding spirals in galaxies proves galaxies are designed. But it's another piece of circumstantial evidence in a growing pile of anomalies.
The most ambitious plan is still in the proposal stage: a dedicated FRB array in lunar orbit. The Moon's far side is the quietest radio environment in the solar system, shielded from Earth's radio interference, perfect for detecting faint signals. A network of radio telescopes there could monitor the sky continuously with sensitivity far exceeding any Earth-based facility. Such an array could detect FRBs in real time, track repeaters continuously, and potentially respond to signals, transmitting radio pulses back toward FRB sources, attempting to establish two-way communication. The estimated cost? $15 billion over 10 years. NASA has expressed interest, but no funding has been allocated. Politically, it's a hard sell, spending billions to search for signals that might be nothing more than neutron star hiccups. But if the FRBs are messages, if there's even a 1% chance they represent communication from extraterrestrial intelligence, then not building that array is the greatest missed opportunity in human history. Which brings us to the philosophical question underlying everything: do we want to find out? If FRBs are natural, they're fascinating physics, a new astrophysical phenomenon that will teach us about extreme states of matter and relativistic processes. We'll write papers, build models, maybe win some Nobel Prizes. Business as usual for science. But if they're artificial, if we're detecting the scattered transmissions of technological civilizations spanning the universe, then everything changes. We're not alone. We never were. The galaxy, maybe the entire universe, is populated by intelligences capable of technologies that can outshine galaxies, that can beam signals across billions of light years, that operate on scales we can barely comprehend. And they've apparently stopped talking to us. What would that mean? Why go silent? The optimistic interpretation: they're waiting, testing, seeing if we can figure it out on our own before they make direct contact. The pessimistic interpretation: they evaluated us through our response, or lack thereof, to their signals, and decided we're not worth contacting. Too primitive, too divided, too dangerous. And if civilizations billions of light years away, with technology millions of years more advanced than ours, are struggling to survive, what chance do we have when that threat reaches us? Speculation, all of it. We have data, thousands of FRBs, tantalizing patterns, suspicious coincidences, but we don't have answers. We don't have certainty. We don't have communication. We have the silence. And silence, as they say, is the loudest sound of all. Now concluding this journey, we began by asking why repeating FRBs suddenly decreased by 97% in late 2019. The honest answer is, we don't know. The conventional astrophysical explanations are incomplete. The technosignature hypothesis is speculative, controversial, and lacks definitive proof. We're left in an uncomfortable middle ground, unable to confirm the signals are natural, unable to prove they're artificial. But the question haunts us: what if we're living through first contact and don't realize it? What if the universe has been trying to talk to us for years, and we've been too distracted, too skeptical, too focused on our own problems to listen carefully enough? The next decade will be crucial. New radio telescopes are coming online. Machine learning algorithms are getting sophisticated. Our ability to detect, localize, and analyze FRBs is improving exponentially. If the repeaters resume their pre-2019 transmission rates, we'll have the data we need to definitively test whether they carry information. We'll be able to decode patterns, extract structure, maybe even construct meaning. And if they don't resume, if the silence persists, that might be the most profound answer of all. Confirmation that something changed in 2019, something significant enough to alter the behavior of sources across cosmic distances. Here's what we know for certain.
Fast radio bursts exist. They're real. They release incomprehensible energy in milliseconds. Some repeat with patterns that look suspiciously non-natural. They've been extraordinarily useful for studying the intergalactic medium, testing relativity, probing cosmic structure. But underneath the science, underneath the careful papers and conservative conclusions, every astronomer who works on FRBs has wondered, late at night, staring at the data, whether we're seeing something more. Whether the universe is trying to talk to us, something we're not quite smart enough to understand. The silence continues, the mystery deepens, the search goes on, and somewhere out there, across billions of light years of space, in galaxies we'll never visit, around stars we'll never see, something is generating these signals. Natural or artificial, random or meaningful, accident or message. We don't know, but we're listening, and maybe, just maybe, they are too.